As part of our series on CDS Views, we will be learning about the concept of joins and how we go about creating inner joins in CDS Views. First of all, let's have a look at some theory. In case you are already familiar with the concept of the inner join, you can skip the theory part and go directly to the coding. Let's consider a database table that stores the material master information. This table has the columns material number, material type, and the material group. The data in this table would look something like this. As an example, we take the material with the material number steel 101. It has the material type raw material and the material group carbon steel. Let us now consider a second database table, and this would be the purchase order information table. This table has the columns purchase order number, material number, so the material that was ordered as part of this purchase order, and the quantity that was ordered. The data in this table would look something like this. As an example, we see the purchase order number 45001. We had ordered 5 tons of the material steel 101. Now let's say you want to build a view on top of these tables. So a view that collects and consolidates information from both these tables into one entity. A view that essentially brings these tables together, or in other words, joins them. And if you think about it, this view is going to give us information about which material has been ordered in which purchase order and how much of it. These two tables are logically linked to one another. The materials that you put in a purchase order are essentially the same materials which are stored in the material master table. So this is why we say they are logically linked to one another. And this logical linking of the two tables based on a common field is what we refer to as a join. Why do we need it? The whole concept of join is to establish a link between two or more logically related tables. So data from different tables can then be consolidated into one view under one roof. The logical link between these two tables is what we refer to as the join condition. In this case, the material number field from the material master is equal to the material number field from the purchase order table. We say that the material master table and purchase order table have been joined based on this join condition. We can use elements from both the join data sources for defining the elements in the join view. For example, in this case, I want the elements material number and material type from the material master table, and the elements purchase order number and quantity from the purchase order item table to come into my view. The field material number is of course common between both these two tables. As you can see, I have left out the field material group in my view. You don't need to include all fields from your source in the view. Before you construct a join, it is extremely important to understand the logical relationship between the database tables. You have to really understand how the tables are related to one another. And the easiest way to do that is to see the fields that are common between them. In this case, for example, the material number was the common field between both of these tables. There can be more than one field which is common, and you use those fields then in the join condition. There are different ways in which two or more tables can be linked to one another, or in other words, we say that there are different types of joins. And the first type of join that we will be looking at is what is called as the inner join. Let's take the same example that we had seen earlier, the material master table, MARA, and the purchase order table, EKPO. These two tables are logically linked to one another based on the material number field, MATNR. Now let's say I want to build a view that gives me the following output. I want the view to return the material number and the material group from the MARA table. Along with that, I also want the view to tell me the purchase order numbers under which these materials were ordered and how much of the material was ordered in that particular purchase order. For example, the material steel 101 has the material type raw material It was ordered in the purchase order 450001 with a quantity of 5 tons. So this record from the material master MARA table has to be joined with this record from the purchase order EKPO table and presented as one single record in the output of the join. Similarly, the material battery 75 has the material type semi-finished. It was ordered in the purchase order 450002 with a quantity of 30 pieces. So this record from the material master MARA table has to be joined with this record from the purchase order EKPO table and presented as one single record in the output of the join. Now, uh, this is very important. Please have a look here. The material battery 75 was also ordered in the purchase order number 450003 with a quantity of 10 pieces. So the same record from the material master table with the material number battery 75 has also to be joined with this particular record from the purchase order table with the PO number 450003. So this results in another record presented in the view output having the same material number battery 75, but this time with the purchase order number 450003. So effectively we have two purchase orders that refer to the same material battery 75. And that is why you see two records in the output, one for the purchase order 450002 and one for the purchase order 450003, but with the same material in both of them, battery 75, like this. And finally, if you see the material the material steel 1 or 2 was not ordered at all in any purchase order. So therefore, I do not want to see it in my output. So this type of a join in which we combine records from the left-hand side table, MARA, and the right-hand side table, EKPO, whenever there are matching or same values in the fields which form part of the join condition, such a join is called as an inner join. So that's it for the theory part. Let's code now. Okay, so I have created a basic CDS view entity here already. In case you're not familiar with the process of creating a CDS view entity, please check out the first video in this series on ABAP CDS Views. So a brief look at this CDS view entity that exists already. It's defined with the name ZI underscore material underscore purchase. The annotation end user text label is used to provide a description to the data definition. And currently this view entity is defined as a select from a single data source, the MARA database table, and we retrieve the columns material number and the material type. Our final goal is to build a CDS view entity involving an inner join on top of the data sources MARA and EKPO like we had discussed during the theory part of the video. So as of now, there is no join in the CDS view entity. We only retrieve data from a single data source, which is the MARA table. If you open this view using the Dependency Analyzer and then proceed to the SQL dependency graph, you can see a graphical view of how this view, CDS view entity is currently built. So this is the name of the CDS view entity. As you can see, the number of used data sources is 1, and that one data source is the MARA table. Let us now extend this view entity to include a join. We can of course use the predefined templates to generate the syntax for a view entity join, but I suggest typing the code out manually to get a better grasp of it. The first thing to do is to provide an alias name to the data sources. This is not mandatory, but it improves the readability of the code tremendously. We provide an alias first to the MARA table like this, as select from Mara as underscore material. So the name of my alias is underscore material. Once the data source has been provided with an alias, we qualify the names of the fields from this table with the same alias. The next step is the MARA table has to be joined with EKPO. The join type that we are using is the inner join. We provide an alias name for the EKPO table as well. Finally, we have to specify how we want to link these two tables or these two data sources logically. In other words, we specify the join condition. In this case, we know that it's going to be the material number. So we use the keyword on, and as we know, field names are always qualified with the aliases. So this is my join condition that has now been specified. So now we have extended our basic CDS view entity into an inner join between the tables MARA and EKPO. We have also specified aliases for the relevant tables as underscore material and as underscore purchase item. And then we have also specified the join condition. At the moment, we only have columns from one of the data sources. Let's go ahead and add in some data columns from the second table as well. Let's put in the purchase order number. Let's put in the purchase order item. Now, whenever we purchase something, there's always going to be a purchase unit of measure. For example, kgs or liters or pieces, something like that. So let's add in the unit of measure. That's the field MEINS from the EKPO table. And finally, let's add in the purchase quantity. That's the field MENGE. Let's save and activate. We end up in an error. Let's have a look at the error log. So it says that the field quantity, since it's a quantity field, needs a reference. And that reference is going to be a unit of measure. Now, if you think about it, you cannot have a quantity field without a linked or referenced unit of measure. So you can't just say, I want to buy 5 of material steel 101. It just doesn't make sense. I need to specify a unit. So let's say I need 5 tons of steel 101. That makes sense. So this is the quantity, and this is then the reference unit of measure. You also notice this phenomena when you create a quantity field in a custom table in SE11. Even over there, we specify a referenced unit of measure field. Now, the way to do this is you use an annotation at semantics.quantity.unit of measure right above the field definition for the quantity. And here, so this is the name of the annotation, and for the value of the annotation, you specify the unit of measure field, which in our case is UOM. So what this annotation does, it informs the compiler that for this particular quantity field, the referenced unit of measure is the field called UOM, which is in effect the MEINS field from the EKPO table. So this is how we build a quantity unit of measure reference in CDS view using this annotation. So let's compile it and activate now. A quick look at what's happened in the Dependency Analyzer. You can now see the view built as a join on top of two tables, the MARA and the EKPO tables. If you see here, the used data sources, the number of the used data sources is now 2, there is one join operation involved between the tables MARA and EKPO. Another important aspect to be noted here is that the select is done from the MARA table. So that's why you see the SQL relation from. And this is then joined to the EKPO table. That's why you see the SQL relation inner join. So MARA is our table on the left-hand side, and this is inner join to the table EKPO on the right-hand side. Let us now have a look at the data returned by this join. As you can see, the CDS view entity consolidates data from both the MARA and EKPO tables, brings them together using the inner join approach, and then this is what is then displayed over here. So let's have a closer look at this. If I right click on the material number column, I see the option distinct values for material number. It tells me how many records exist for a particular material number. So for example, this material has a count of 65, which basically means that for this one record from MARA with the material number, whatever this is, there are 65 records in EKPO. So let's scroll down this list and we see that the material RM15 has a count of only one. So let's filter our results based on this material. We use the add filter option, material number, RM15. We have just one record here. What this basically means that the material RM15 was ordered on just one occasion. Or if we speak in technical terms, we say that there is exactly one record in the table MARA with the material number RM15, and there is just one record with this same material in the EKPO table. This is why you see one record when you do an inner join on these two tables. Let us now look at another material, and this time we take the material TG13. We see multiple records being retrieved. This is because this material was ordered many times, as you can see, in different purchase orders. Or technically we can say that for one record with the material number TG13 in the MARA table, there are multiple records in the EKPO table with the same material number, but of course, different purchase order numbers, different purchase order quantities. Inner join retrieves all of the common records. Let's have a look at the MARA table in SE11. We have here, for example, a material with the number 11. Let's copy this number, jump over to Eclipse, and filter our results for this material number. Now we see that the inner join does not really return any entries. The reason being, inner join only retrieves common records. Although a record with this material number, what I have used here, does indeed exist in the MARA table, which is our left-hand side table, it, however, does not exist in the EKPO table on the right-hand side, which basically means this material was never purchased. So it exists in the left-hand side table, but not in the right-hand side table. This is the reason an inner join will not retrieve such a record. It's not common to both the tables. Let us now extend our inner join to a third table. Let's say, along with the purchase order info of a material, I also want to know the material text, which comes from the table MAKT. We extend the syntax. So we already have this. And we continue further. We specify the join type. We specify the data source. Specify the alias. And finally, we specify the join condition. Now we go ahead and add fields from this third data source into the CDS view. We want the material text and the language fields. Save and activate. A quick look at the Dependency Analyzer. We can see that the view ZI_material_purchase is now using three data sources, the MARA, the EKPO, and the MAKT tables, and there are two join operations involved at the moment. MARA with EKPO and MARA with MAKT. And finally, let's see the content returned by the CDS view entity now that we have joined three tables together. Let's filter to the same material RM15. Now, if you remember, when the view had just involved MARA and EKPO, we had just one record for this material. But now you see multiple. This is because the material RM15 exists exactly once in MARA, exactly once in EKPO also, but multiple times in the MAKT table, which basically means that the description of the material is maintained in many languages. All records with material number RM15 from MAKT are retrieved. You can see over here all the different languages. The values from the MARA table and the EKPO table are simply copied over. That's why you see all the records have the same material number RM15, the material type, the purchase order number, the purchase order item, and the quantity are going to be the same for all of the records. They exist just once in MARA and EKPO, but they exist multiple times in MAKT table. So finally, a brief summary of what we just saw in this video. A join logically links two or more data sources using a join condition. In our example, we had created a join on the tables MARA, EKPO, and MAKT. A join condition refers to the conditional logical linking of two or more data sources based on fields that are common between these data sources. In our case, it was the material number field which was added in the join condition. It was the common field which linked all the three tables together. An inner join retrieves records that are common to both the tables involved in the join. In our example, we had seen the material number RM15 had one record in the MARA table, and there was one record for this material in the EKPO table with this particular purchase order number. These two were then joined together using the inner join. If the join condition field has a certain value in the left-hand side table, and there is no match for this in the right-hand side table, it will not be retrieved by an inner join. This is the reason why the record with the material number 11 was present in the MARA table, but it was not present in the EKPO table, and therefore it was not present in the view output. Vice versa, if the join condition field has a certain value in the right-hand side table, and there is no match for this in the left-hand side table, it will also not be retrieved. If the join condition field has a certain value in the left-hand side table, and there are multiple matches for this in the right-hand side table, all of them will be retrieved. So that's all for now. I hope this concept of inner join is clear to you now. I would suggest trying this out in the system before proceeding on to the next lesson. In the next video, we will be seeing about another type of join called as the left outer join and the right outer join. Thank you and keep coding.